Welcome to Math Made Easy by Suman Matthews. Today we embark on an enlightening journey into the world of hypothesis testing, learn about null hypothesis and alternate hypothesis, learn the rejection rule for p-value and critical value. You'll practice questions on the one-tailed and two-tailed test, learn how to read the normal distribution table and memorize the level of significance for different confidence levels. Learn the interval estimation to test two-tailed hypothesis and how to test the hypothesis for population proportion. So what is hypothesis testing? We make an assumption about a population parameter called the null hypothesis and denoted by H0. So the null hypothesis is denoted by H0. We define another hypothesis which is the opposite of this. This is called the alternate hypothesis denoted by HA. So HA is the alternate of the null hypothesis. Now hypothesis test for population mean where sigma standard deviation is unknown. You have H0 mu is greater than or equal to mu naught, HA mu less than mu naught, or H0 mu less than or equal to mu naught, HA alternate hypothesis mu greater than mu naught. Both these are called the one-tail test. Now if we have H0 mu equal to mu naught and HA mu not equal to mu naught, that is the two-tailed test. So two-tailed test is basically when you have not equal to. If H0 is true and we accept H0, the conclusion is correct. If HA is true and we accept H0, then we have made a type 2 error. So type 2 error is when we accept H0 when HA is true. If H0 is true and we reject H0, we make a type 1 error. If HA is true and we reject H0, the conclusion is correct. So type 1 error is when we reject H0 when it is true. Now, the level of significance alpha is the probability of making a type 1 error. Now you have the test statistic Z, which is defined as x bar minus mu naught sigma by root n, where x bar is the sample mean, mu naught is the hypothesized value of the population mean, sigma is the population standard deviation, and n is the sample size. Now we have the lower tail test, upper tail test. I have just kept a table here. If you have mu greater than or equal to mu naught and HA mu less than mu naught, this is a lower tail test. And test statistic is Z equal to x bar minus mu naught by sigma by root n. We reject H0 if the p-value less than or equal to alpha. Upper tail test is when mu less than or equal to mu naught, HA mu greater than mu naught. And the test statistics is the same, rejection value is also the same, critical value approach is also this. We reject H0 if Z greater than or equal to Z alpha. You need to memorize these. So critical value is different for the upper tail test. We reject H0 if Z greater than or equal to Z alpha. Two-tail test, the test statistic is the same, rejection value is the same using the p-value approach. Critical value is slightly different. You reject H0 if Z less than or equal to minus Z alpha by 2 or Z greater than or equal to Z alpha by 2. Now you have the level of significance alpha, and these are the levels which you need to remember when you are doing problem solving. So when it is Z is 0.2, Z alpha is 0.842, 0.1 Z alpha is 1.282, 0.005 it is 1.645, 0.025 it's 1.96, and these are the values which you more or less need to remember. Coming to problem solving, consider the following hypothesis test. H0 is mu less than or equal to 25, HA is mu greater than 25, so it's the lower tail test. A sample of 40 provided a sample mean of 26.4. The population standard deviation is 6. Compute the value of the test statistic. Now what is the parameters given here? Mu naught is 25, n is 40, x bar is 26.4, sigma is 6. The test statistic is given by Z equal to x bar minus mu naught sigma by root n. Substituting you get 26.4 minus 25 by 6 by root 40, which is 1.48. What is the p-value? Now p-value, your Z is 1.48. P-value of 1.48 is the area under the standard normal curve to the right of Z. So I will just look at, this is the 1.48. So 1.48 will be here. You have 1.4 and 8. That is 0.9306. So we have it is area under, because it's area under the normal curve to the right of z, so that is 1 minus 0.9306. And this is what we do when z is greater than 0. So that is 0.0694. So the p-value is 0.0694. So you need to remember that when z greater than 0, the p-value will be 1 minus whatever value you are getting from the table. If alpha equal to 0.01, what is your conclusion? So p-value is 0.0694, which is greater than 0.01. So we do not reject H0. That's a condition. If p-value is greater than Z alpha, we don't reject it. What is the rejection rule using critical value? What is your conclusion? What is the rejection rule? Reject H0 if Z greater than or equal to Z alpha. Now Z alpha will be Z 0.01, and that is 2.326 from the table which I had asked you to remember, and Z is 1.48, which is less than 2.33, so we do not reject H0. Coming to the next question, for the following hypothesis test, H0 is mu equal to 15, H1 is mu not equal to 15. So this is a two-tailed test. A sample of 50 provided a sample mean of 14.15. The population standard deviation is 3. Compute the value of the test statistic. So mu naught is 15, n is 50, x bar is 14.15, sigma is 3. So your test statistic is x bar minus mu naught by sigma by root 10. That is 14.15 minus 15 by 3 by root 50, which is minus 2. What is the p-value? Your z is minus 2, which is less than 0, and for a two-tailed test, p-value is double the area under the normal curve to the left of z. So if you look at the normal curve corresponding to minus 2 corresponding to 0 is 0.0228. So you get it as 2 into 0.0228, which is 0.0456. So your p-value is 0.0456. At alpha equal to 0.05, what is your conclusion? So your p-value, which is 0.0456, is less than 0.05. If p-value is less than z alpha, we reject H0. So we reject H0 here. What is the rejection rule using the critical value? What is your conclusion? And according to the critical value, you reject H0 if z less than or equal to minus z alpha by 2. Minus z alpha by 2 will be minus z 0.05 by 2, that is 0.025, which is minus 1.96. And minus 2 less than minus 1.96. This is from the table which I had asked you to remember. So we reject H0. Now what happens when you have the interval estimation to test a two-tailed hypothesis? So let H0 be the null hypothesis, that mu equal to mu naught. HA be alternate hypothesis, mu not equal to mu naught. Select a random sample and find the sample mean x bar, and we develop the confidence interval x bar plus or minus z alpha by 2 into sigma by root 10. If the confidence interval contains mu naught, we accept H0, otherwise we reject H0. So this is slightly easier to remember. So again consider H0 is mu equal to 295, alternate hypothesis is mu not equal to 295. A sample of 50 provided a sample mean 297.6. The population standard deviation is 12 and level of significance alpha is 0.05. Use interval estimation to check the hypothesis. So mu naught is 295 and n is 50, sigma is 12, alpha is 0.05, mu is 297.6. So z alpha by 2 is z 0.025, which is 1.96. Your confidence level is x bar plus or minus z alpha by 2 into sigma by root 10. That is 297.6 plus or minus 1.96 into 12 by root 50. So this will give you 297.6 plus or minus 3.3. Which is the interval? 294.3, 300.9. And 297.6, 95 lies in this confidence interval. So we accept H0. Now we have one more hypothesis test for population proportion. For a lower tail test, if H0 is P greater than or equal to P0, that is a null hypothesis, alternate hypothesis is P less than P naught, your test statistic is Z equal to P bar minus P naught by square root of P naught into 1 minus P naught by N. The p-value approach will be we reject h naught if p-value less than or equal to alpha. Critical value approach reject ha if h naught if z is less than or equal to minus z alpha. For an upper tail test where you have this condition, z is the same, we reject h naught if p less than or equal to alpha and reject h naught if z greater than or equal to z alpha. That is the critical value approach. You need to remember these. For a two-tailed test, the test statistic remains the same. We reject h naught if p-value less than or equal to alpha, and critical value approach will be reject h naught if z less than or equal to minus z alpha by 2 or z greater than or equal to z alpha by 2. So consider the following hypothesis. H naught is p greater than or equal to 0.75. Alternate hypothesis is p less than 0.75. A sample of 300 provided a sample proportion of 0.68. What is the value of the test statistic? So P naught is 0.75, N is 300, P bar is 0.68 and Z equal to the test statistic P bar minus P naught by root P naught into 1 minus P naught by N, that is 0.68 minus 0.75 by root 0.75 into 0.25 by 300, which is minus 2.8. What is the p-value? Z is minus 2.8, which is less than 0. So p-value will be area under the normal curve to the left of Z. So if you look at minus 2.8, you get it as minus 2.8 will be 0.0026. So it is minus 0.0026 because you have a minus here. Now what is the rejection rule if alpha is equal to 0.05? If p-value less than alpha, we reject it. Minus 0.0026 is less than 0.05, so we reject h naught. What is the rejection rule using the critical value approach? Now z alpha is z 0.05, which is 1.645, and we have minus z alpha is minus 1.645. Minus 2.8 is less than minus 1.645. So if z less than minus z alpha, we reject h naught. So that concludes this topic on hypothesis testing. So we've journeyed through the significance levels, p-values, and the critical decision-making process that underlies hypothesis testing. May the concepts we have explored today guide you through the exciting world of data analysis. If you found this video helpful, like, share, and subscribe for more enlightening content.